It's Baby Friday! Welcome to the O-Scope Wizard Show. I am Gabe, the O-Scope Wizard. I have my good and plenties. I have my hipster water. I had a really funny story about Tiger Balm, which I will relay to you last night. It was suggested by Mrs. Oscilloscope Wizard that I cover my hands in a healing salve called Tiger Balm, which is kind of a mixture of cinnamon and menthol. So after, my hands, by the way, are quite sore because I've been working around the house doing some handyman projects, trying to do some stuff on my car, and it has led to very sore hands. So last night, after reading and laying down, I put on this Tiger Balm, menthol, cinnamon, and began to drift off to sleep, but then needed to jump up and use the bathroom, so jumped up, used the bathroom, and then things took a turn for the worse because I had Tiger Balm on my Tinder bits, which is not what Tiger Balm is intended for, because it is not only menthol, cinnamon, it is also white fire. So the rest of the night was spent avoiding the Tiger Balm. I had turned my hands into weapons that were attacking my own self. Luckily, I did end up drifting out to sleep and had a good night's sleep, and it is Baby Friday, favorite day of the week. Thank you for joining. The last episode that we had, I think that might have been funnier the first time before the audio cut out. The last episode ended on a cliffhanger, which is what I was trying to show you. We were trying to create a real-life necklace that will display subtitles or closed captioning when you wear it. So as you speak, it will display your words across your chest so that we can overcome hearing people through masks. Masks are great. I wear a mask hanging out with folks, and masks are everywhere. Masks do wonders, but they do sometimes make it a little bit harder to hear people. So I'm like, huh? What? I can't hear you. So I thought if you had a small microphone that sat near your mouth and then displayed the text that you were saying across your chest, people could read that, and maybe it'd help everybody hear better. I know when I'm watching TV, we have to turn on the subtitles to be able to hear it better. I think it might be because my ears are getting old and I like music loud. But we were starting at the beginning, trying to just get our LEDs working. I have a whole bunch of NeoPixels. You can see I've got this whole huge strip of NeoPixels, and I have a second strip of NeoPixels. The first step was trying to get them turned on and, displaying light. And when we tried to get everything going, we kind of got stuck here installing stuff. And isn't that the case? Every time you deal with software, it feels like you've got an update. And luckily, the last episode ended up here, right here. And the next episode, today's episode, begins with it installed. So we should be able to turn these NeoPixels on, hopefully. I want to turn them on to see how much current they are drawing. To run this whole thing, I bought a battery. This is called the Pi Bat. It's a tiny battery that uses I2C to actually talk to the Raspberry Pi. I think it's to allow the Raspberry Pi to turn itself off gracefully. And it also supplies the 5 volts out, and I was going to use this to power the NeoPixels as well as the Raspberry Pi. I just didn't know how long it would last. It says that it has 1600 milliamp hours or 1.6 amp hours. And if I can determine how much current my system uses, I can estimate how long everything will last. That's how battery life works. We want to try to sip current at a very small rate so that our battery life is elongated. Now, let's get back into turning on these NeoPixels. So it's really simple. We're going to make a example piece of Python code again, and then we are going to just turn them on, right? We're going to fill everything with light, presumably. That's what our hope is. That's what our hope is. This is how we started. In fact, this is how we started using the NeoPixel in our last quest to do our Raspberry Pi amplifier. So I need to make a test. So we will call this. Whoop, get my keyboard working. Why? Why is my keyboard not working? That's weird. It was literally just working. I mean, I typed things in. I just hit Control. Well, maybe my batteries died. That's good. Timing, because I have a couple of batteries. That's really weird. I'm talking about battery life, and my batteries died. And you know what? While I'm at it, start the timer. Start the timer. I'm looking at it. We're starting timers, changing out keyboard batteries, talking about battery life. Whew. Got a couple of AAAs here. And Baby Friday, though. Baby Friday. Nothing can make Baby Friday a sad day, I don't think, because it is just inherently awesome. Okay. What is happening now? Why am I not working? My mouse is working good. My keyboard, on the other hand, is working less good. Let me get the receiver out for my keyboard. It is a wireless keyboard. This is my own fault. I should get a wired keyboard. Let this be a lesson to everyone. Oh, you know what? You know what it was, guys? You know what it was? I think my keyboard was working, and I just did a whole exercise in futility there because my Raspberry Pi, for some reason, rebooted. Uh-oh. Uh-oh, why is it rebooting? Why are you rebooting, sir? Looks like it's booting up now. Do I have the ability to talk with it? I do not know. I'm going to be bested by a keyboard with dead batteries. I think the keyboard still had dead batteries because the other day I had to, you know that trick where your batteries are running low and you pull them out, you twist them around a little bit, or maybe you just twist them around, trying to get that last little bit of juice out, like shake the chemicals up. Come on, batteries. Do what you're supposed to do, sir. All right, let's try to SSH back into my Raspberry Pi. You gonna do it, buddy? We gonna make it happen? I think we're gonna make it happen. I think we can. I think we can. I think we can. I'm watching the LED right here to see. It looks like it keeps rebooting. Okay. You know what we'll do? Gonna make it a little bit easier on ourselves, and we're just gonna plug. We're gonna plug this little USB connector into my Raspberry Pi. Let's get it into the power slot, though. So there are two slots over here on the Raspberry Pi, one for USB and one for power in. We want the power in. Okay. Okay, now we have the power in, we have the power. Every time I say we have the power, in my mind, I think we have the power of Grayskull. I watched so much He-Man when I was a little guy, and just basically every time power is invoked, if you say the word power, in fact, I will think Grayskull. Power of Grayskull. I can't even help it, honestly. getting up there. Yes, okay, we're back. We are allegedly back. We have it. We're going to log back in. Okay, now, other people have the power. I see it in chat. I have the power. I have the power of Grayskull. Let's have a couple of good and plenties in honor of epic vintage cartoons. Did anybody else watch He-Man when they were little? Or was it just me? Was I the only one? Certainly I wasn't the only one because it was a wildly popular show. We will call this NeoPixel test, I think. NeoPixelTest.py. All right. Oh man, yes. He-Man and G.I. Joe for Randy in the chat. That was a perfect combo, I think. He-Man and G.I. Joe. I spent so many Saturdays watching He-Man and G.I. Joe. And then Dungeons and Dragons, I think, was right in that same mix. And when I was really little, and I was really into Saturday morning cartoons, we lived in the middle of nowhere in Mississippi. So a very small town, Silver Creek, Mississippi. And we had an antenna that was on a pole hanging off the side of the house. And I remember my dad going out occasionally and trying to repoint that antenna. I'm like, Dad, I can't see He-Man. Turn the antenna a little bit so we can see. And then he'd get it and we all run out. Stop, it's perfect. We can see it a little bit through the staticky hiss. Anyway, fun times with antennas. Let's check, back to the task at hand. Let's check which pin I actually connected this to. So I have this little breakout board and it looks like I'm connected to GPIO 12, which is what we wanted to be connected to. So I need to make a little bit of change to this code. Well, a couple of changes to this code. First, let's change this to be on D12. And then the number of NeoPixels is 256. That's a lot of NeoPixels. And then let's add a command to fill them up and see how much current is drawn. That's the idea. If we just do NeoPixels or pixels.fill, we'll just copy this into our test program. Pixels.fill, let's fill it up with everything. So white light, 255. I think that will burn the most power. I think that'll burn the most power because that'll be, each NeoPixel has 3 LEDs in it. So if you turn all of the LEDs to maximum brightness, that should be the maximum amount of power allowable. So now we'll save this. Yep. And we'll run it and we'll see if these turn on and what happens. I don't know what'll happen. Let's get a good view of it because when it does happen, it's going to be exciting. Sudo python 3 NeoPixel. Oh, it did work. Let me turn off some lights real quick to see if we can see it better. Hold on. Okay. Now I'm like in the deep dark, but we want to see this flash a little bit more, I think. Let's see. I believe there's I think there's an easy clear command. I think there is. Or I guess I could just write all zeros to it. Let's start a little loop. Let's start a little loop. Sudo nano NeoPixels. Let's to do the loop, we need some time, so we will import time. What if you could really import time? We will make a loop while true. Boom. Get this over here. Boom. And we will do time dot, is it sleep or wait? You guys remember? Sleep or wait? Which one? I can't remember. Time dot sleep. Time dot sleep. So we will time dot sleep it. And sleep 1. And then we'll do pixels dot fill 0, 0, 0. And then we'll try it again. Time dot sleep 1. While true, we'll do all these things and it'll just loop. So the idea of this loop is it's going to flash on, flash off, or turn off, flash on, and it should do that every 1 second, I think. Let's go back to our board and see if it works. Very exciting. While true. Wait a second. True's not defined. True is definitely defined. True. It's true. Wait a second. I forgot how picky Python is. Not true. 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 Uppercase true. Man, Python. Man, Python. Python's not the only thing that's picky. I mean, I should have noticed it there. You know, Nano's trying to tell me, yo, man, I didn't turn it pink or a color. If I turned it a color, it means it's a real thing. If I didn't turn it a color, it's not a real thing. Okay. Well, you can probably see it blinking over there on the side, but boom. Boom. That's awesome. That is awesome. We have blinking like we literally have blinking lights. Let's leave those blinking, but I'm going to turn lights back on. Lights are back on. We are continuing the camera and the action. But one strip of LEDs is not as cool as 2 strips of LEDs. I want to see if I can string these things together. Let's pause my my NeoPixels, and I want to add a second LED strip to this first LED strip, and they have these little connectors that let you just gang them together. So you plug, if I can get my, there we go. Oh, let me get my camera on it so you can actually see what I'm doing. It's 2 little connectors here that mate, and you should be able to gang tons of them. So I'm going to just plug these in, which makes my connection so much easier. Thank you, NeoPixels, NeoPixel folks, for thinking of that, or the people who made this double set of light rings. Now, I don't have 256 LEDs. I have 2 times 256, which, if math serves me, is 512. So I need to change this from 256 to 512. And that should tell the Raspberry Pi that I have 512 of these little NeoPixels connected to D12. So please, when you send out your pulses, send out enough for 512. What do we think? What do we think? Is it going to work? Let's go see. I had a Spanish teacher in high school that always said, vamos a ver, vamos a ver. From my understanding, that means let's go see. Vamos a ver. Oh, I can see that. Well, you can't see this, but they are changing colors. Instead of bright white, they are more of an amber. So they've changed colors. So I think that they're a bit current starved going through the Raspberry Pi's GPIO. which is not entirely surprising. I think ultimately I'm going to have to bypass the Raspberry Pi's GPIO to make all of this work and just plug the battery into the Raspberry Pi and separately into the NeoPixels. It has some little ports right here that enable that, so you can have a parallel connection. Vamos a ver. Vamos a ver, we're going to see. Vamos a ver. Vamos a ver, I was... Vamos a la playa, we're going to the beach. The chat is helping me. Vamos a ver. We're going to go see. We're going to see. Let's go see. Vamos a ver. Man, you know what? I had so much Spanish in school. You'd expect me to be able to speak it better. It is really a travesty of my level of language. I just do not have a great gift of language. I want to measure some current. So that is going to require a couple of leads. And I have my trusty, handy, dandy multimeter back here, the old HMC8012. It is a great little guy. I'm going to disconnect my Raspberry Pi because I want to go back to powering it. I know it didn't work, but I want to go back to powering it with the GPIO right here. That way I can measure, I want to be able to measure the current of the whole system, right? Instead of just the LEDs, I want to be able to measure both the LEDs and the Raspberry Pi. Let me turn that so you can see me while I'm working over here on the side. Okay, to measure current, remember we have to break the circuit. We have to be in series with the circuit to measure it with one of these guys. So I will plug the red into the blue A, because that makes tons of sense, and the black into the common. And I am going to measure the current going from this little board. Actually, I can just take out this red wire right here, and I'm going to feed all the current through my trusty HMC. Let's put my J-clips to the test. I have these headers. Let's see how good they are at staying on headers. I noticed they can get a little loose. I wonder if there's different brands of J-clips that are a little bit more tightly toleranced. Have a tighter tolerance? I don't think that was English, bro. Current. No, DCI. I want DC current, 1/2 amp. Okay, so right now, if you can see it, we are measuring 500 milliamps while the Raspberry Pi boots up. So it's booting up, getting its life right, trying to start. And we're gonna vamos a ver. We're gonna vamos a ver how much current this thing is gonna use. What I should have done is made a service. Maybe that's what I should do ultimately. Make a service that flashes an LED to let me know that it has booted. I will say on my last project, the amplifier, when it boots, I have the LEDs like do this little pattern that just shows you that the amplifier is turned on and ready and working, and I found it very useful. And I probably should add that to this project as well. Let's see if we can connect back to the Raspberry Pi, or if it has panicked. It has closed the connection. Let's terminate the process. We're down. We're down. I think it's up though. I think it it seems like when I'm powering it this way, it's going into a boot loop. I wonder why it would go into a boot loop when I'm powering it through the GPIO. I wonder if my USB adapter, you know what? This is behaving like the USB adapter doesn't have enough giddy up to power it. So typical. So typical. Well, let's see if it's still down. Control C, yeah, it's just having trouble booting up. That's okay, because you know what I have? I have a, wait a second, is it a dearth? Wealth? I can't remember. What was the word for plenty? A goodly number of DC to DC converters. Oh! And I have my old trusty homemade power supply here that we were using. This is a 12-volt power supply that can do 30 amps. There is no way this Raspberry Pi will take more than 30 amps. And I have some cables here that we can make everything work. We'll make it all work. Let's change how we have things connected. Holy moly. Oh, man.
5 minutes remaining!
Now, 5 minutes remaining. So on the last episode, I actually set this to 5 minutes to keep myself on track, because I've noticed my 5 minutes tend to be more like 45 minutes. So 5 minutes, we're gonna keep it rolling. Keep it rolling, 5 minutes. Let's get a power cable out of the drawer, power cable out of the drawer, the magical drawer that holds tons of probes and AC power cables. Now, power to the power supply. Moving quick, moving quick. I don't move very quickly. That is not my specialty. My specialty is kind of slow moving. Really? That's what I'd usually move at. So my in is 14.9 volts. My output is 12 volts right now. That would be a non-ideal situation for my Raspberry Pi, so let's lower it. Only working with the highest level components here. Definitely not. This is a $3.25 DC to DC converter. So this is pretty high-tech stuff here. 6 volts, getting there, getting there. Da da da. 5 volts. 5 volts. We have the power supply set to 5 volts. That is an acceptable level for my Raspberry Pi. I will now connect up my Raspberry Pi to the ground. Let's put the ground in first. So that is ground on my Raspberry Pi. Let's turn that down a little, or point that down a little bit. And ground of my power supply. And now, power. Now we're going to plug this into the business end of this power positive. Okay. Okay. You see everything's, well, you probably can't see, but it is drawing power here. The Raspberry Pi's light is coming on. Let's lower this down so that we can see the current reading. I say, like the current reading, not the Current reading. Current. English might need more words. English might need more words. I struggle with the words that it has, but sometimes it doesn't have enough, or even the right ones. Current and current. I mean, the current flow of electrons, and the current as in now. Is it going to connect? It looks like the Raspberry Pi is booting up. It is booting up. Its green light is on. It is drawing 600 milliamps, which is kind of surprising, considering it's not doing a whole lot except booting up. Although in the boot process, Raspberry Pis do tend to use maximum amounts of power, but they have to get over that hump. But it hasn't turned on its server yet, so I don't think it's connected to the Wi-Fi. And for whatever reason, doesn't want to boot up. Doesn't want to boot up. We might need to do some investigating on why this Raspberry Pi doesn't like booting up. Because it definitely does not like to boot up. Makes me almost want to hook up the monitor out of the Raspberry Pi to see what is happening. Perhaps in the next episode, we will not only measure the current of the Raspberry Pi, but we will also watch the boot process through the monitor output, since it doesn't seem to want to boot all the way up. It's just stuck at 600 or 590 milliamps. The green light is on, but not blinking. Oh my gosh. Oh my gosh. That was 5 minutes. 5 minutes goes by mighty quick. Mighty quickly. So, that's okay. Next episode, we have more stuff to do with the Raspberry Pi. This is how you guys are seeing how projects really go. They go in fits and starts and slow, but we have now a more powerful DC to DC converter involved. I don't know what this means for my battery. My batteries are usually pretty good at sourcing current, but they will just, run out faster. 600 milliamps. I mean, if it just sticks at 600 milliamps, it's really easy. 1600 milliamp hours would not last very long if I drew 600 milliamps. What would it last? Not even 3 hours before it was completely drained. On the next episode, we'll have a monitor plugged into the Raspberry Pi so that we can see the boot process and where it's getting stuck. And who knows what else? Maybe we will finally measure the current draw of all those NeoPixels, which is what I want to do. And then we're going to hook a battery up to it. And then we're finally going to get the microphones hooked up to it. Actually, we'll probably do the microphones before the battery. We'll hook the microphones up to it and try to get the microphones working, which could be pretty exciting. I'm pretty excited about this little board right here that has 2 microphones on it. That's all for the future. Thank you so much for hanging out with me for the Oscope Wizard Show on this baby Friday. You guys have a wonderful weekend, and I will see you next week on Band Shirt Tuesday. I just ordered a new band shirt right before the show because I'd run through all my band shirts and I wanted a new band shirt. So see you guys on Band Shirt Tuesday. I don't know all the nerds in the world, but I'd love to meet them. So please share this with a nerd in your life, and I will talk to you later. Bye.